Thank you and good evening, or let's say good night, for staying so late and having patience. I admit that the previous two talks were very technical. There were nice stories and there was high tension. So I will have a challenging task of still keeping your attention. This is more of a consulting talk. But I'll try to make it equally thought-provoking for you so that you can have some takeaways when you go home or when you go to the pub afterwards. How many people here deal with open source risks? Anybody? 1, 2, 3, 4, 5, 6. Okay, and another question, how many people deal with or consume open source? Okay, yeah, so I was expecting a higher number in the second case. That confirms that we all, or almost all of us, have some connection to open source software, either as a consumer or author or whatever. The goals of tonight's presentation, the first 2 points are quite entry-level complexity, so very easygoing. We'll look at the open source risks, and I will go beyond security. In fact, I will also be talking about other types of risks that you can encounter in different roles. We'll have a look at the solution. I'm not going to suggest one solution because maybe we'll have different opinion, each of us, and everybody maybe prefers another solution. Okay, so there are many dependencies. And I hope that when you leave this talk, you will think about maybe how you can apply this in your current environment, in your job, or maybe when you have a project at your customer's place. And in the end, when you have some kind of experience that you want to share, we'll be happy to hear it. And also others who are sitting in the audience. Very typical agenda for such a talk, introduction, then motivation, why we should care about the risks, what the solution could look like, and how we could implement it in practice. A little bit about myself. I started working in cybersecurity a long time ago. At that time, there were not so many domains. It was mainly cybersecurity and IT security or network security. Later, I switched to software security. It's very, very tempting and very interesting. And I worked in several roles. Currently, I lead, I have a software security champions program at the Czech bank, which is working more with processes, with people, and a little bit less with technologies or with technical things. Let's go to our motivation. So in 2024, maybe you will be surprised by the very high number of some statistics here. First, let me explain. So there are many vendors nowadays who conduct some kind of survey or research. Yeah. So if you are writing a SaaS tool, then maybe you have some research connected to static analysis. And so Black Duck is a company that is providing. They have they have their tool for scanning open source, and so they have some statistics every year. This is taken from the report 2025, and they are claiming that 97% of the code bases that they examined contained open source. 97%. Okay, and then not surprisingly, more than 80% contained at least some vulnerability. Yeah, and out of it, a lot of this was high or critical vulnerability. The most commonly found vulnerable component, and it has been like this for a couple of years, is a jQuery. Yeah, so this demonstrates that some of these components are Java or JavaScript specific. Apache Tomcat, also very popular server. So if you think that this slide was boring, then I have maybe something hopefully more interesting. So you can see here we have screenshots of articles, recent articles, May, April, March 2025. You see 3 categories of problems, or I don't want to say vulnerabilities, because in these cases here you see it's something malicious. So it has been created to be malicious. We have malicious packages, in both cases NPM, but it could be any other ecosystem that is being consumed by developers, by engineers, or even you can have it from your provider that is writing code for you. Then we have typo squatting, and here on the top right bottom we have vulnerable package. And this is in fact what we are going to pay most attention to tonight. We are going to talk about vulnerable packages. This is I would say, the traditional domain of open source security, although in the recent years, 2-3 years, we have a lot of malicious intentions as well. How come that we have so much open source software in our software? I would say the first two avenues are quite natural, because we have, in our companies, we have some approved components in our Artifactory, maybe even out of some official repositories that we can consume. It could be containers, it could be container images, it could be some libraries. Developer can maybe download something, maybe unofficially, maybe officially. Code reuse is a bit special, because imagine that you go on Stack Overflow and you use a code snippet, you put it into your source code. Maybe it's coming from open source component, maybe not. And nowadays we have AI that can also generate code, and this code can also maybe stem from some open source component. So it could be that it's very difficult to find a source code snippet in the source code, but it still has some risks. It could be the same risks as those bigger components. And then when you are consuming some outsourced development, you could also, maybe you just have a binary component, but you should also expect some open source inside, very, very typically. So we have a lot of avenues, and that brings challenges for us, which we will look at now. So challenges, we will have different hats, not real hats like Martin did, but virtual hats. And first we will be a CIO sitting in the car and smiling, but already thinking of some open source challenges. So think about this. You have a lot of applications in your portfolio, and you want to know, are we using open source at all? Because maybe he needs to report it to CEO, and he wants to know, okay, are we using open source at all? How much do we use? How dependent are we on open source? And then if we have some kind of security event that we want to ask, are we using this component, for example, jQuery 1.5, or maybe it will be without the version, just jQuery. Are we using jQuery in our code? And do we have any policy in how we are consuming open source software? Is there any policy in the tool? Do we have any test? Do we have any control? And how do we benefit? Of course, it's not only about the governance, it's also about how do we benefit from using open source. So if we summarize it, the CIO or management would like to know their assets, okay? And here you have example of assets, okay? So we have components, names, and their version. Let's move on to the next role, which is a CISO, or it could be an application security manager. And they have a little bit deeper look at things. So first of all, they want to know if they have any vulnerabilities in the open source software that they are consuming. What are the critical and high vulnerabilities? And imagine that there is some kind of reported alert or advisory, that's the better word, advisory, and it tells you, okay, there is a big vulnerability exploited in this open source component, and it has to be this version. And so the CISO will calm down and talk to the team, okay, tell me quickly, are we using this component, and to which extent? So how impacted are we in reality? And then another question is, nowadays, it's not only about the vulnerable components, but do we also have any malicious components? Because there are a little bit different ways how to detect vulnerable ones and malicious ones. Yeah? And so we have, fortunately, we have OWASP Top 10, where already since at least or at the latest 2013, we have a category called using vulnerable outdated components. And so we should prioritize this also in our testing. We also have a CVE, so it is recognized as a weakness category as well. Now we have compliance team, I think our favorite team. So a compliance team, they want to have some kind of policy and governance on, okay, are we distributing our software which contains open source? What do we do with this software? They should also set some policy. And so there are some rules on how we are dealing with our open source software. Well, and if you think that this is just a minor detail, then I have two examples for you, two cases. The first one is one commercial company versus another commercial company. So there is a company called Artifact Software, and they developed an open source interpreter. And this interpreter was used. So they developed this interpreter, and they decided for this to have two types of licenses. There will be commercial license, so you would have to pay if you want to reuse their interpreter, and you don't want to release the open source of it, or you don't want to release it as open source. And then you could also have a GPL license. Okay, so you could decide which one you want to use. However, this company called Hancom Incorporated, they decided to use the interpreter, and they didn't want to pay, so they said, okay, we will use the GPL license, and we will not release our source code because it's our intellectual property. So somehow they got informed about this, and then they ended up here in front of the US District Court. Okay, so then they had to find an agreement somehow, and they were not able to continue monetizing this kind of interpreter. So I would say it's maybe not a big financial problem, but it's kind of a shame for the company if they don't respect the law. Yeah. And then we have another case, which was kind of, I would say, first case that when a community was suing a commercial provider because they released a software for a TV, and they were using some open source component with GPL license, and they didn't want to disclose the source code of this operating system. So it was also interesting proceeding in this case. We'll spend just quickly a few minutes here so that you understand some main license families and schemes. We have copyleft, copyright, so copyleft types of licensing scheme. It's quite restrictive, okay? And if you ever make a scan or test of your software and you find this license there, then you can slap yourself on the face because it's very, very risky. So it means that even if you are just hosting this software as a service, and you have a component with such a license, you would have to disclose its source code of your software. So you don't have to distribute it. It even applies if you are just hosting it via network. So this one is really dangerous if you have it. This one is still dangerous, a little bit less dangerous, but it's the classic GPL license, which is telling you that you also, if you distribute your software, for example, mobile app, you would have to publish its source code. Then we have weak reciprocal. It's again one step lower in the terms of risk, and it tells you that you don't have necessarily to publish the entire source code, but you still have to publish the source code of the part of your solution which is using this open source component, because you have to publish all the changes that you did in the source code related to this open source component. Then we also have non-commercial licenses, which are different to these licenses, because these copyleft licenses, they do not prevent you from using these components for commercial purposes. You can still sell your software as long as you publish the source code, but here you are prohibited from using this for commercial purposes. Okay, then we have risk number 4, which is operational risk. I think this is quite relevant to developers, engineers, and here we have to decide, okay, are we going to use this open source component, and is it well maintained? How many commits does it have? How long does it take for a new security fix to arrive? So for example, if there is a vulnerability, do we have to wait 1 month, or maybe we have somebody in our team who can fix it? So you have to think about plan B maybe. Maybe there is no new update, maybe something else will happen. There are other risks. For example, you could think about, okay, I have some open source component, it's not well documented, I don't know what it's doing, it's pretending to be safe, but maybe it's sending some data, personal data, some non-GDPR compliance, so it's really important to have some kind of due diligence for open source software. Okay, so this was painting clouds on the sky, but now let's think about what we can do with it, and there will be a couple of solutions. We can define 4 steps, out of which, if we are security persons, then we should actually pay attention to all of them. And first of all is, I think it's similar to security. When we are in the security world, we cannot determine risks for something we do not know. So we need to have the list of material, we need to know what we have, what kind of assets we have, and then we can think about the risks. In this world, or in this open source world, we have something called SBOM, Software Bill of Materials. And it means that it contains all my components, all my open source components, and it contains the vendor name or supplier name, then the component name and the version. And when we talk about SBOM, we can abstract it a little bit higher. So when you produce a software, and this software can contain open source, maybe some proprietary components that you have, maybe some third-party commercial components. Actually, SBOM should contain everything, not just the open source parts, but everything, okay? It should be complete. So SBOM is also something that you could ask your provider when you are a customer and you tell them, okay, can you please develop some software for me and then provide it to me in the binary format, but you should still give me the SBOM definition so I know what is actually in your software. So moving on to the point number 2, you should also understand the relation between different components. You can have direct dependencies, which you can easily see when you look at the manifest file. And you can have transitive dependencies, which are the dependencies of the dependencies. So, for example, in the beginning, you see, oh, there are just 8 dependencies. It's an easy piece of software. And then when you build the application, you see there are hundreds of components because there are multiple levels of dependencies. So it can really grow up high. Then in the software bill of material, you should also see the license information. It's not talking about the risks. It's just telling you, okay, you have the component A and it has the license GPL. Or maybe it says license unknown. So and then you would have to dig deeper and try to find the license that you need to consume or make your decision based on. So we have 2 main formats of SBOM, of the SBOM standard, and it's good that OWASP also have their Cyclone DX format. Then there is SPDX by the Linux Foundation. Both of them are highly established. They are open standards. They are still being developed. There are new versions. Okay, and you can find their definition, for example, on GitHub. You can then use this definition. You can decide which fields you want to use. Some of them are mandatory. Some of these are optional. Also, there are multiple flavors. For example, for this purpose, we have SBOM. But if you want to exchange vulnerabilities or compliance information, it will be called differently. It will be BOM, but it will not be SBOM. It will be different type of BOM, bill of material. And so, because it's not really meant to be used by people, it has a machine-readable format. For example, it could be XML or JSON. And then you can import it to some tool, or you can get it from another supplier. This is just to demonstrate some fields, commonly used fields here. So you can do things like, okay, you have metadata, you have supplier name. I was already talking about this, but you also have ways how you can protect data integrity of this SBOM. So you could hash it. You could do cryptographic hash of the SBOM. The entire SBOM, so it's not manipulated on the way from your provider to you. And you can have things like license information and even some vulnerability information, but it's optional. Here are 2 examples. We have Cyclone DX here, which is also containing some vulnerability information with CVSS scoring and the vector description. And then we have SPDX on the other side, and this one, for example, has a checksum here. I know it's very small, but it's there. Okay, so now we were talking about the first step, which was know your assets, okay? And now when we have our assets, we can think about the risks. Those two risk categories on the left, so this is something that we want to take care about when we work in security. This on the right side, it's more, okay, this is compliance and this is operational, so it's maybe not us, but we should definitely be interested in this part here on the left. And SCA is something called software composition analysis. Maybe you heard it before. So this is a type of analysis that will provide at least this and this and this, and sometimes it can also provide this kind of risk. So now we know our risks, and now we have to do something with them. Okay. So now comes the fun part, because it's not always that straightforward. First of all, when we have our SBOM, we can think about, okay, so we have 100 components in it, and do we need all the 100 components? And so we can look, and sometimes we see components, these are just meant for test. These are some components meant for building, so we can remove them for the production release. They are not relevant. Or maybe I don't know this component, let's remove it. So this is the first step. Remove what you don't need without breaking your application. Then you can continue here or here, but let's go to the security risk. So here it is a bit of speculation or discussion. So usually it could be a discussion between the developer, a security folk, and maybe some pen tester. And it would be, okay, so for example, I have some remote code execution. So do I need to remove all the components straight ahead? Well, depends, because it depends on the threat model of your application. Maybe it's not directly exposed to the internet. Maybe there is a vulnerability which is saying, if you are using a function from this library, it doesn't treat the input parameters sufficiently. Okay, but maybe you are not using or calling this function in your source code. So you need to have this kind of discussion, okay, so that you have the context and you really determine the right risk that you have in your application. Not everything which is critical is really critical in the end of the day. Also, we have something that helps us. So a few years ago, knowledge base was mainly looking at some static databases, and that was it. But nowadays we have some very dynamic knowledge base, which some tools are consuming, and they help you determine the exploitability of the attack vector here. And then we have treating licensing risk. So here the best thing is to have some policy in place. It should not be just, okay, we performed our SCA analysis, so what should we do now? We don't know. We should really have some policy which is set by the compliance team. And we should know the product context, meaning, are we distributing the product? Are we hosting the product? Is it just used for internal purpose? Maybe it's just intranet. So we should know, because this determines how big our licensing risk is. And then we have operational risk, which is you need to monitor your components and remove everything that is not maintained. Okay, so now we have the last phase. So imagine that we did all the due diligence, we did all the preventative controls, but it still may not be enough, because something may still end up in the production release. There might be some channel to sneak through and go into production. And so here we have a lot of controls that are linked to data integrity, okay? So when we think about this, it's not so much about confidentiality and availability. Of course, it's always important, but it's mainly data integrity. How do I protect source code to be changed without my knowledge, without noticing anything? Do I need to sign my software? I need to sign my release. I need to sign my binaries, and I need to verify them. I need to verify who has access to my binary repository. And do I have any contractual obligations towards my supplier, or the supplier towards me, and so on. There is actually a very nice picture or diagram. If you go to SLSA, I will talk about it on the next slide, which is showing 9 attack vectors linked to supply chain, okay? So what we are talking about mainly is open source security, but the bigger picture is called supply chain, something that was also mentioned in the previous presentation. And you have so many attack vectors here that you can make a kind of threat modeling exercise and think about how your environment is protected. So supply chain attacks, it's a very thrilling area, very, very interesting. There are so many attacks recently, and so it's so creative, it's unbelievable. You can see 700% increase of attacks. And I would say the main takeaway here is, of course, we should always be protecting our products, but it's not enough. You should also protect its environment, and not only the production environment, but nowadays Jenkins, build environment, IDE, where maybe some plugins are downloaded. So everything needs to be protected, and it's not only about production. SLSA is supply chain levels for software artifacts, and it's an initiative, or we can call it framework. You can, for example, verify if you have sufficient controls in your environment. You can document your controls according to some methodology. You can send them to your customers saying, oh, I'm doing my due diligence, I have processes, I have some tools that I'm using to sign my artifacts. So you have different levels here, and you can rate yourself, do some kind of benchmarking. Okay, so now let's move on to the practical side of things. And this was a lot of theory, so now how we can perform this SCA analysis. There were some old methods, maybe you've seen some of these before, manual discovery, so I'm just doing some kind of maybe command line invocation, and then I can see some components, and then, okay, so this time I'm clean, but maybe next time we'll see. There are no ongoing controls. I can have spreadsheet, which doesn't scale at all. If you have a spreadsheet and you have all your open source components in the spreadsheet. You may have some vulnerability testing, which is better than the previous two parts, but still it's only point in time. And so we need to have something that scales and is designed for open source. First, let's talk about controls that we all know from the current, I would say, from the current practice. So we have static application security testing, which is looking for software security bugs and flaws. And here there are advantages. We can find even some unknown vulnerabilities, okay? Because I can scan my proprietary source code, but if I have also the source code of my provider, I can also scan the source code of my provider. Plus, I can scan the open source. So I can actually scan everything. And the good thing is that if I have already SAS, then I don't need to implement anything additional, so it's very good. On the other hand, it's not comprehensive enough, so it will not tell you I have looked at all open source components, so it's just opportunistic. You will not have any software bill of material, and it doesn't look at licensing. So it's okay, but it's not enough. Then we have later in the stage, in the life cycle, we have, let's call it all dynamic testing. It could be manual testing or automated testing. So I can find some flaws, misconfigurations, vulnerabilities in the apps. And also, when we are using those tools and pen testing, sometimes in the report you can see, there is an old version of some components. It could be open source component, it could be maybe some proprietary software, which is old, so that's very good. But it's the same problem that SAST has, which is it's not comprehensive, no bill of material, and it has less false positives than SAST. So this is another advantage, but it's not comprehensive enough. Now we are coming to some more modern methods when it comes to open source detection. Now we have source code repository checks, which is very elegant because it's very developer friendly. You don't need to implement any additional stage in testing. It can be triggered automatically, and you have continuous monitoring. Okay. So there is some basic license compliance. It doesn't look at the code snippets. Okay, and it might also look at things which do not go into production later on. So it doesn't have this production a context. And we have two examples here by one platform, so GitHub Dependabot, which is very easy to use. You can set up some policy, but it's not mandatory, and then you can get some alerts if you have any outdated components, and it will even suggest you a pull request, which you can accept. if you don't break the application, and then you can upgrade to a newer version. So this is good, and you have the same thing in GitLab. Then we have another way of controlling things, which is a binary repository. So once we have our software which we build, then we can push it to Artifactory or some kind of binary repository. And this is also another very natural way to check for open source problems or risks, because again, you don't need any additional stage. You can do this for containers, you can do this for mobile apps, you can do this for any binary, so it's very elegant. On the other hand, it's not very good coverage. It doesn't work, in my experience, very well for the compiled code like C, C++. And also, it's not really meant for the license compliance. It's more about security here. So 2 examples here, X-Ray, JFrog, or Sonatype Lifecycle. These are 2 commercial solutions. Now we are coming to another solution, which is a standalone scan. Okay. And here, the good thing is that this is really something that's designed for open source scanning. So it means it has a few false positives, it has detailed information, it's not just an add-on to something which is already existing, and it is faster than a SAST or DAST, which also applies to the 2 previous solutions, binary and source code repository. The disadvantages are that you already have several testing methods. You have SAST, you have DAST, and now you also have to implement the SCA, so it creates an overhead. And the disadvantage is that you will not find any malicious components usually, and you will not find unknown vulnerabilities. Okay, so here it's mainly about something that has been reported, so it has a CVE or it has maybe some vendor security advisory, but it will not find any unknown vulnerabilities, any 0 days. And here I will mention 2 OWASP tools. We have dependency check, which is the older one. Dependency check is good if you want to start with SCA on your own, you don't want to pay, and it's a standalone analyzer. Okay, so you can do a standalone scan, or you can use it as a Maven plugin. You can use it in Jenkins. You can use it in some other build process. So it's easy to be integrated. And also, it focuses on security. Okay, so it's mainly about the security vulnerabilities that you have, and it looks at your current state. It's not very good at telling you where you should go. So here it doesn't suggest which is the secure version of the component. But we have something different, which is called OWASP dependency track. So this one has a big advantage. It has a GUI. And also you can actually see some trends, you can see some metrics, and you can even use it, we can call it platform. So the previous one was more a standalone checker analyzer that runs, it doesn't run as a service, it's just some binary that is running in the background, and then it stops when the test is finished. And this one can run as a service. You can run it as a container. And then it has a database, and you can import SBOM from some third-party software that supplier gives you. So this is a great advantage, and it will also do monitoring for you. So if there are any new vulnerabilities, it will tell you that you have a new problem. And the great thing is that this OWASP dependency track works with some very good databases, or let's call it intelligence. So it has EPSS, Exploit Prediction Scoring System, which is kind of a machine learning model, and it's every day it's running again, and it will tell you historically and for the last 30 days what's the exploitability chance. Okay, so this is very good, and it doesn't only rely on the NVD database from NIST. It also relies on some other databases. So it provides very good intelligence. Okay, so then we have 2 tools I wanted to show you. There are tools also that are specialized more on the license compliance, OSS Review Toolkit, and Fossology. You can use them open source. As open source, you can also, of course, there are some commercial models, but just for demonstration. Okay, so moving or coming to the end. So here I want just to briefly talk about the integration. And we already have SAST, IS, DAST, and some other ones. We have the life cycle here. And so you can see that SCA can be quite varied. It can be started as a source code repository check in the very beginning. It can be done as a binary repository check a bit later after your build. But it can also, if you have a standalone solution, then it depends. Yeah? It depends on the programming language, depends on other circumstances. If you don't develop your software, of course, you cannot do it here. You have to do it here somehow. And if you have your own code, then it really depends on the language. For C++, you would for the best coverage, you would have to do it here in the beginning. And for some other non-compiled languages, you can do it during the build when you have all the dependencies that are downloaded to your environment. So yeah, that was it. And thank you for your attention. And if you have any questions or if you want to share your story, how you are dealing with open source security, that would be interesting to hear.
Great talk. I like the way you structured it and gave a full rundown of the entire set of issues that this comes with. Great job. Thank you. I wanted to see what was the largest pool of dependencies you've managed.
Oh, okay, that's already the end of question. Okay, so I think when I worked in my previous company, I was working with open source, and we had large Java and JavaScript applications which had 300 to 400 dependencies.
We're dealing with about 20,000 today.
Okay. Good luck.
Manageable when it comes to particular licensing. Security issues are still relatively manageable, but licensing is a hell. It changes day to day, back and forth. And if anybody has any experience or advisory that we could gain, I'm looking forward to some other discussions in the department.
Do you have any policy around that, around the licensing?
Yeah, but it's just the brute force of issues that roll in every day, and having to kind of go through them.
Okay, thank you for your story. Yeah.
You were mentioning dependable, and quite recently I had a discussion with my colleagues, like, what would be the, let's call it, proper setup, right? Because with as many dependencies as we mentioned here, like a couple of thousand, you get pretty much the PRs, even on non-critical issues, kind of daily, right? Which is really demanding for the developers, especially if you create the application. So what are maybe your recommendations based on your experience to set it up properly, and if there is some, I don't want to call it corner cutting, but how to optimize the weight of security and developer time?
Sure. Okay, this is a very complex question. I will not be able to provide you straight away recommendations, and I'm not that familiar with Dependable, so I work with it, but not to that extent that you are working. So I don't know about the best practice configuration for Dependable. It's a very difficult discussion. So I think it has to be a discussion maybe at some more high-level approach. You know, sometimes it's also about who is stronger in the organization. If it's very highly regulated, or if it's maybe more engineering-led organization where it's not that strongly controlled. But it's hard to give I would say single recommendation here. So I have seen organizations which silently accept this, and they will maybe only look at some. They have some application profiling, so they look at applications which are maybe crown jewels, and it could draw high attention. So they are dealing with these applications, and but it's hard to look at everything. We did, for example, a very large project for one automotive company in Germany, and they had thousands of applications. We did a lot of scans, and guess in the end of the day, it just was a pile of paper on their table, and they were not able to find an agreement on all those steps. So we were only looking mainly at high critical things, and for the licensing, it was tough.
I have a question about like looking for those malicious components, because you said like it's a little bit different approach. So maybe you could say a few words about that, how you like approach this problem.
So for the malicious components, what I have seen is that they are accompanying some kind of it could be some kind of similar to vulnerable components. So you would also have some kind of intelligence that telling you, okay, this is malicious. It's not vulnerable, but it's malicious. So please take care of it. And if you want to know straight away if it's malicious, then I would have to say you would look at some kind of metadata around this package. Just look at some how trustworthy it is. Look at some I would say index how much you can trust this component. But it's not something that you can easily detect. Yeah. So I would say you should look at some other mitigating controls that I was showing previously, SLSA framework, where you are observing how this component is behaving, and you have maybe some network segregation. You are not just letting any outbound traffic happening and so on. It's very hard to detect malicious components.
From what I've seen was the excellent approach was to gain the knowledge, because the developers are using the malicious components. Usually they gain the public knowledge just right after they use it. So it has you get to have audit data with components were downloaded, and the best approach is always use some proxy repository, and you have to have the malicious code carrying on the repository. So later you have the info who downloaded it, and you can make some corrections.
Well, if it scales, that's very good, because it's very dynamic nature of things, and something that look legitimate in one commit or one release could be suspicious, and you could have a component which appears to be behaving normally, but then in the post build or post install script or step, it will just download another malicious or another but malicious component. So something which is legitimate, and then it has just one URL, and then it will download something malicious. So it's I would say it's hard, but also there are some commercial tools which are primarily looking at vulnerable components, and they have currently some let's call it machine learning /AI / they have some additional modules that also can look at the malicious components, but it's still, I don't know, it's still not very mature, I would say.